Namaskar, welcome back. So, this was the last part which we discussed about the erosional landforms in coastal environment, and we were talking about the sea notches, and we already discussed about that how sea notches are been formed. So, this was the part which we were discussing from the Neil Island, Andaman, and we see almost like here four uh, sea notches. And now we also discussed about that these are because of the erosion of tidal waves, and they indicates past sea level. And then we were talking about that how these notches are formed. Okay. Further, as we were talking about, this is the youngest sea notch which we are having here between this and this. Okay, which is at present where the erosion is taking place. Now, the question remains that whether this was or this notches were formed because of the sea level change, which was related to your climate change. And if we talk about the climate change, then we are talking about the uh, sea level rise, okay, and sea level fall. Okay, so this could be related to that. Okay, but here, since the sea notches are exposed, okay, we see the exposed sea notches. Now, this exposed sea notches indicates that this was the level where we were. If we go to back here, so this was the level of the sea at that point of time. Okay, so this indicates that. So, whether this has happened due to sea level change, and this again indicates the sea level fall. Okay, so whether the sea level has fallen so much that it has resulted into the different sea notches which are exposed. So, these are the questions which usually we keep uh, in our mind when we are looking such landforms. Okay. So, let us move further and see, and other than that, okay, what we also see very clearly is the terraces. Okay. So, this flat surface, if you look at, this is of all marine uh, rocks, we can say. Okay. So, these are the flat surfaces which we can see here. So, these are typical what we call marine terraces. Now, these marine terraces also are indicative of sea level fall, okay, because this indicates sort of an wave cut platforms. Now, another example from this was from Andaman Island, where again we saw multiple sea notches. So, that clearly indicates that this is the sea level has gone down, and then at the same time we also see these are the wave cut platforms. Okay. Now, on top of this again there is a wave cut platform. So, this is if we say wave cut platform 1 over here, and this is wave cut platform 2, and we have at the same time the sea notch here. This is a very typical mushroom shape sea notch, which is the of course developed in a rock, but yes, it indicates the paleo sea level uh, in the past. Now, taking into account the sea level and the sea notches which have been formed due to erosion, and sometime it is because of the that what we call the sea level fall or tectonics. Okay. So, tectonic uplift can also expose your sea notches, because you see, suppose for example the sea notch is forming here and this was a sea level, but if it goes up, then this has been exposed. Okay. Now, there was a very like we would say that there is a good example from Japan of an earthquake which took place or occurred in 1703, and this was in Boso Peninsula and Mura Peninsula, where they were able to see this type of multiple sea notches. Okay. So, this is the figures which have been shown here are clearly indicating the uplift, amount of uplift which took place in Boso and Miura. And a Japanese team, they also dated uh, the organisms. Okay, that is mostly the molluscan, dead molluscan shells, and they dated and they were able to uh, identify that they were alive at this period. After that, they died. Okay, because the molluscan cells will always uh, remain at mean sea level, or and then and within the tidal range. So they dated these organisms, okay, dead organisms, molluscan cells. That was been done. So elevation measurements of uplifted marine shells, okay, indicates that the lower assemblage emerged during 1923. So this whitish part which you see here is the dead molluscan cells. Okay. So that they have correlated with 1923 earthquake, whereas the uplift of the upper assemblage is has been correlated with 1703 Kanto earthquake. So they were able to justify this, that the such uplifts, okay, in the coastal regions could be related to, because the sea level was at this point during 17 and then it has gone down. That means there was during this phase, actually, if you say a few centuries back, okay, there was no such climatic fluctuation which could have resulted into the uplift of this coastline. Okay. Not uplift, but the sea level fall, but there was no climatic fluctuation. But earthquakes were responsible for emergence of this coastlines. So this was very clearly identified in terms of the different events, and further this was again another platform. This is an erosional platform you see here. So this is what we call the wave cut platforms. So this wave cut platform, that means the sea was at this level in the past, and which resulted into the uplift of the surface during 1923 earthquake. And then uplift, if you measure, we measured there was around 1.5 meter or so. Now the present day wave cut platform is this one. Okay, so this is the, so if I say that this is the older one is this one, and the recent one is this, actually you have. So this is the present day erosion which is taking place in this area. So similar evidence was also been identified, where they were able to date the oyster cells, okay, dead oyster cells, and which gave the age of around, and where the age, and based on the age they were able to correlate with 1923 earthquake. So such evidence and signatures we try to look at in the coastal regions where we have active tectonic deformation going on, and that is mainly the subduction zone areas where such processes will be operating and can give an examples or the evidence of this type of movement. Okay, not always the movement is like uplift, it may have subsidence also, and that what we were able to gather from our research in Andaman and Nicobar region. Okay. So we have seen this and discussed also about the headland, bay areas and the cliffs and all that. Now further we move about this also we have seen about the the arc, okay. And from Andaman also I have shown that along with the sea notches. Now, wave cut or shore platforms, which I was showing in the previous slides also, they are horizontal surfaces formed along the rocky coastline. So, this is very much important because if you are not having the rocky coastline, then you are not going to see the sea notches and the terraces also. Okay, terraces may be there, but wave cut platforms and the sea notches as well as the other features, to some extent terraces also, you will not be able to see if you are not having. Now, this is an example again from Andaman Island, Neil Island, what we are seeing. So, you have a terrace here where you can see this topography over here. Okay. So, this is a terrace uh, over here, and this is your wave cut platform, okay, or wave cut shore line platforms. Okay. So, wave cut platform is there. So, this is the present day erosion which is seen. Now, suppose this gets uplifted or the sea level falls down, then this will be seen as a sort of an emerged area. Coming back again to the Andaman Island. So, as I was showing that we were able to identify multiple sea notches. So, this is one sea notch what we are having. There is another one which is forming over here actually, okay, and which is the very small one, recent one. And then we have one over here, and then another here, and then third. It's a bit eroded, but this is the part of the sea notch, okay. At the same time, we are also able to demarcate the wave cut platforms, okay. So, you have the sea notches here. So, sea notch 1, 2, 3 and 4. Okay. Of course, this we have not marked because we were not very confident, but this could be a sea notch actually here. So, but anyway, the most prominent landforms and the indicators which we were able to pick up was this is the present day wave cut platform, this is one, another one, and this definitely will be the third one, okay. And then we have the sea notches over here. So, this clearly indicate that the right now as we see that the erosion is at this level, the earlier the erosion was at this level, and before that it was at this level. So, wave cut platforms will be, if you see carefully, then you will have the sea notch, okay. So, you have sea notch, and then you are going to have the wave cut platform, okay. And then if you have another sea notch, then this will be the wave cut platform what you are having, okay. So, this is your wave cut platform, and sea notch here, and wave cut platform and sea notch. So, this WC0 is been associated with your N4 notch, okay, and this WC1 will be with this one, okay, and this WC3 will be probably this one. This is C notch only, okay, and then you have like that, okay. Then rest part is eroded, it's not been seen, okay. So, you have multiple sea notches which clearly indicates that there was an sea level fall in this region that could be related to your climatic fluctuation or could be related to your tectonics. Okay. So, if we have the ages of the sea notches which we are trying to date, okay, still we haven't got success. Okay. So, if we date the sea notches, then we will try to see that whether there was some sort of an climatic perturbations during that time span. If not, then we will correlate this with the tectonics. Okay. That means during mega events, this area got uplifted, or the Andaman Islands were been uplifted. Okay. So that you can reconstruct the paleo events, ancient events during the geological past. Okay. Another picture, but this wave cut platform which you see has emerged, okay, because of the uplift in 2004 Sumatra Andaman earthquake. And this is from the eastern, not eastern, western coastline of Andaman Island. So, what does this photograph indicate? This was been taken immediately after the earthquake. We flew over this area and then we collected such information. Okay. So, if you remember the formation, this is a beach here. Okay. So, you have beach here and this is your the wave cut platform, you can say. Okay. So, low tide used to be up to this, okay, earlier, and then high tide, when you go, then this process, okay, backwash and swash will result into the formation of your beach. But since this area was uplifted by almost like uh, 0.9 to 1 meter, at some places it was around 0.5 meter also, this uplift was there, and this was along the west coast. Now, this portion is exposed. Okay, this whole portion is exposed. So, the low tide now is restricted along this line. So, what will happen is that beach process will start developing over here. So, this will get extended and you will have the formation of beach here. So, such change in the environment are also important to understand the influence of climate or tectonics. Okay. So, we also try to see the marine terraces. Okay. So, as we have learned in the fluvial landforms, the step like features are very much similar here also. So, this marine terraces are indicative of the process which is operating over here, okay, the present day. So, you have multiple steps here which have been seen. So, this indicates that this was the area where earlier sea level existed. Okay. So, it says ancient sea cliffs. Okay. So, these are the cliffs actually. Okay, you can see, and that what I was showing in the Neil Island, one of the terrace. Okay. So, these are all sea cliffs you have, and the flat areas what you have is your terraces, marine terraces. So, we have in total here, if we see, then we have T0, then you have T1 and then T2. 3 level of terraces the sketch suggests. Okay. Now, let us see if probably if I am having this slide and all that, so then that we can look at. So, wave cut benches and terraces usually are in association, as I explained, that you have the active beach, okay, and then you have wave cut benches, and then associated you have the sea notch here, and the top flat surface will be your terrace. Now, suppose there is an sea level fall. Okay. So, either the sea level fall or you say there is an uplift. So, this was stable. Then in that case, you see this is one terrace and this is another one. Okay. And now the sea notch will form over here. So, there are examples of this type of terraces in Andaman, which we were able to identify from Kamrota Island, which is in the southern portion of the Andaman Island, before we reach the Great Nicobar, that is the southernmost island of India. Okay. So, this is one terrace, then another one is over here, and then finally you see over here. Okay. So there are multiple terraces which we were able to see. However, we haven't dated this, so we don't know that what is the age of this terrace. Okay. And even we were able to see the drowned shoreline. Okay. So this is the drowned shoreline which you see. So marine terraces are one of the most important landforms which talks about or tell us about the past sea level in the region. Now again coming to the Japan example from Boso Island, what they identified here was that they were able to see multiple marine terraces. Okay. And this multiple terraces were formed in a very short span of time, and that is what, of course, it is almost, if you see in the AD 1703 and 1923, these were the two major earthquakes in that region, but they were also able to identify more terraces, and during that period there was no change in the sea level. Okay. So sea level was stable, but they were able to see almost like 1, 2, 3, 4 and 5 terraces. Okay. So 5 terraces, and they correlated this 5 terraces with earthquakes. Okay. That is your mega subduction zone earthquake. Which caused the uplift of this area. So during every event, this area was been uplifted. Because during this period, if you take in 7,000 years or so, it was not so much of sea level fall. Okay. Hence, they have correlated this with different events, okay, in the past. And the most recent ones were 1703 and 1923. Another example of this. Okay. So they say 1703 was Jinriku earthquake, and another one was your Taisho earthquake of 1923. So you have clear cut terrace, which resulted into the uplift of almost like 1.5 meters. But if you see the Genriku, it's almost like you are having from mean sea level. Okay. So above sea level it is been written 4.5 meters. Okay. So this total height is what they say is 4.5 meters. So maybe similar type of earthquakes what they were able to see. If you just double this, then it will be around 3 meter, but Jinriku might have uplifted more of this area. Okay. So such features are, or the landforms are extremely important for us to be noted in the coastal regions. Okay. Now coming to another landforms which are commonly seen, but not as common as the terraces and sea notches. One is Tambola, then you have lagoon. Lagoon is of course common. Okay. And then spit, we have discussed about this, that this will be along shore lateral drift, which will result into the formation of spit. Okay. And slowly, if this spit extend here, okay, further, then it will result into the bay mouth bar, okay, and which will close the portion here and will result into the formation of lagoon. Okay. Tambula is again, Tambolo is, and there is an island here, and then this is all, it is seen that it is connected with some sort of an sandbar or landform here in this region. Okay. So coastal landforms, which we can say the depositional landforms. Okay. So we have seen erosional landforms till now, but let's see the depositional landforms. Okay. Quickly, and so we have beaches, tidal flats, coastal dunes, salt marsh, spit and bar, beaches, beach ridges, then mangrove region and the barrier islands. Okay. and Tambola and natural bridges. Okay, so these are something which are related to the natural bridges. Are of course they will connect the two islands, and then you have sort of a Tambola formation. So we'll stop here, and we'll have more discussion on the depositional coastal landforms in the next lecture. Thank you so much. Namaskar.